Hi, I'm excited and honored to be part of this 10th anniversary of Connect.Tech. I spoke here maybe 4 or 5 years ago, but now I'm back and being able to be here in person is awesome. Being able to see some friends and, hopefully make some new ones. So welcome to Typescript plus React equals heart emoji, I guess. I kind of wish I would have used the fire emoji because that's how excited I am about the partnership between React and Typescript. I want to tell you that the slides are already online. Okay, so if you go to my website, that's benmvp.com, you should find it there. So if you're the type that likes to furiously jot down notes and make sure you catch the slides or take pictures of the slides, it's not necessary because you already got them. So also, if you go to Twitter, I've tweeted out a link to the slides as well. So you should be able to find them wherever you need to. Okay, so, but whenever we're talking about a programming language or non-end user features, we have to ask ourselves, is this really important? What exactly is the benefit? Does it even matter, right? Because if it's not a direct feature for the end user, then it needs to be something that enables us to build something for the end user. Otherwise, we'll find ourselves bike shedding and arguing over non-important things. So Kent C. Dodds wrote this article kind of a while back, maybe 3 or 4 years ago, that talks exactly about that, that we need to measure the success of the tools we use based on how it enables us to deliver features to the user. And the choice of tooling that we pick should solve that and nothing else. But users don't want a buggy experience, right? We don't want, this. And of course, we don't. And most errors that we have in our code don't occur really when we're writing the code. They actually occur when we're refactoring the code. So that refactor can be 2 minutes later, or it could be 2 months later. And that's when bugs get introduced. So I'm going to spend the rest of our time kind of showing you some TypeScript features that can prevent some of these bugs. There's a lot to TypeScript, okay? It's really, really big, so I'm gonna narrow it down to TypeScript and React, so what helps you build React apps. I'm assuming that you know very little of TypeScript, but have been developing in React for a while. But, even if you do know TypeScript, hopefully you'll get a lot out of this. But before we begin, can I get everyone to stand up? Let's all stand up, okay? So, we just had the keynote and maybe you snacked and everything. So I want us to get the body moving, right? So we're gonna do 10 squats like this all together. Yeah, it's really funny, okay? I saw somebody's eyes just pop open, okay? And you only have to do it if you want to, right? It's just fun to get the blood flowing, all right? So let's do it together. I'm gonna count us out. 1, yep, we're doing it. 2, 3, good job. 4, 5, we're halfway there. 6, 7, you can do it. Bend those knees. 8, 9, and 10. Nicely done, nicely done. Okay, so now we are ready to keep going. So just to formally introduce myself, my name is Ben Ilegbodu. I'm a Christian, a husband, and a father. This is my family. On the left is our oldest, Simone. She's 8. In the middle is our middle child, Avery. She is 6. And then my wife, Rashida. We've been married 12 years now. And our son, Asher, he's 3. He turns 4 in January. So we live in this city called Pittsburgh, California. It's in the Bay Area, outside of San Francisco. Not to be confused with Pittsburgh, PA. And our Pittsburgh doesn't have the H on the end. So I think we copied the main Pittsburgh, but we had to be a little different. But actually, we are moving back home to my original hometown, Houston, Texas. So we're moving there at the end of the year. So I am a Google developer expert in web technologies and currently a front-end architect at Stitch Fix. So if you've heard of Stitch Fix before or haven't heard, we're an online styling service. So we like to take technology, data science, pair it with a real human stylist, and we will deliver clothes and other things to you and at the frequency as that you choose. So I also love playing and watching basketball. I really wanted to go to the Hawks game last night, but I flew in last night and there was a speaker's dinner, so, whatever. If State Farm Arena is where the Braves play right there, I would have totally gone, but I didn't want to trek all the way out there. But since I'm from Houston, I'm a Houston Rockets fan, right? It's dark days for us. I heard some groans, it's okay, but we'll be back soon enough. If you remember, the Hawks were the Rockets 4 years ago. So, things can happen. But you didn't come to hear about me, right? You came to hear about React and TypeScript. So let's get started. This first section that we're going to talk about is about props and TypeScript. So one thing I want to make clear first, actually, is that React components are just a function, right? Especially now that we use hooks. There's really nothing special about a function in TypeScript. So really, our React functions are just like TypeScript functions. So we start off with an interface here. That's usually how we define our props. And interface is basically how you define any object, the shape of any object. And it becomes the type of the props that we pass in to a function, okay? So we can name this interface app props. We can name it anything we want. I usually call it props, but in order to make it clear, I called it app props here. Okay, so let's jump in to benefit number one. So with TypeScript, props cannot be used in the component without being defined first, right? So how many times, right, as a React developer, have you gone in, saw a component, and it's using some props that you never saw defined, right? It's like all of a sudden, we have props.loading, but where was that defined? Is that a Boolean? Is that something else, a string? So here we have our definition of app props in the interface, and we defined one prop, message, and we're saying it's a string. So that's the only prop that will be available in our React component. But in this case, right, we're trying to use props.loading without defining it in the interface. So it fails the type checker, as you can see below. Property loading does not exist on the type app props. So, there are various ESLint rules to try to catch this kind of thing, but they're only limited in what they can do. So similarly, we can't pass a prop if it hasn't been defined either. So how many times have we seen props being passed to a component in the render, and it's not in the prop types defined for that component? It doesn't seem to be used within the component code, but we're kind of afraid to remove it because we're not sure. What if it is used somehow? But TypeScript gives us the confidence to remove it because it wouldn't have been valid in the first place. So I'm going to be honest, right? This error message, property count does not exist on type, intrinsic attributes, and app props, right? That's not exactly the most helpful message, right? It's pretty cryptic, even your first, second, third time seeing it. But as you encounter it more, you know how to basically parse it. It's just saying count is not available on the props there. So that's just something that to be aware of as you start out. Okay, so that was one. Let's look at number two. When you look at React prop types, right? they're optional by default. So you do prop types.string, they're optional. So you can add is required, but we all know that doesn't always happen, right? But if you look at the code, you can see that it's definitely required. Like they're doing object dot something, so it has to be there. So these are totally bugs waiting to happen, because if the person looks at the prop types and doesn't see they're not required, or they are not required, then they may not pass it. So the TypeScript interface properties are actually required by default. So without doing anything special, we're guaranteed that those values must exist, which is pretty nice. So here I'm defining app props this time with two properties. We have names, which is an array of strings. Think of prop types.arrayOf, if you're familiar with that. And then we have count, which is a number. So if I call this component and leave off the required prop, we're leaving off count in this case, the type checker will yell at me, and again, it won't compile. And these are who I believe are the top 5 players in the league right now. However, we can use the question mark to denote that this prop is optional. So that is still on the table. And that means that its value is going to be undefined here in the component app. So if I decide to omit count now, when rendering the app, there's no error this time, and its value will default to 2. And within the code, now I'm going to have to check to see if count is undefined or if it has a value. So this is basically how you do default props. You pass in a default to count equals 2, and that works. And it's just vanilla JavaScript. That's not even something special about TypeScript. So let's move on to the third one, right? So if we decide to change the name of a prop, right? We refactor it, right? We want to call it a different, give it a different name because of reasons. So in TypeScript, all the places must be updated. This is kind of related to the first feature in the terms of a property not existing, but let's say that this prop was originally named players, right? And now we later changed the interface definition within the app to names. Or actually, it was originally named names, and we want to change it to players. So we go into the app, we refactor it, right? And we try to do a search and replace to make sure we find all the things that were originally called names and change it to players. But did we catch every single one of them, right? How can we be 100% sure? Well, TypeScript, again, will complain if I am still passing names somewhere. And it'll look something like the error before, like we saw there. And this is something that ESLint just can't do. It can't figure out things across files to know that they don't exist. So a derivative of this is that if I mistype a prop name, TypeScript will complain too. Okay, so far we looked at 3 things, right? We looked at the fact that prop types have to be defined, prop types are required by default, and prop refactors are easily caught when we make mistakes. So let's look at this 4th one, right? It's a lot of work to define a deeply nested structure in React. It's kind of annoying, to be honest. And even with ESLint rules, we can get around prop types.object. There's nothing really forcing me that the prop type definition is 100% accurate. And typically we use prop types.shape to define the structure of an object when we really mean prop types.exact, when we want to warn that they're extra properties. So here we have app props. And it has one property, right? It has one property called user. But user itself is a complex object, and it's defined here with another interface. And the interface name is user. And user has two properties. It has the name of the user and then the address. And the address is another object that has some complex properties, shipping and billing, right? And billing is optional here, got the question mark. And then the address has city, state. It could have other properties that are more complex things. So it's all deeply nested, and TypeScript requires you to specify that whole deeply nested structure. So we can't pass now, because we defined the structure, we can't not pass some properties of it if they're required. So if we try to pass an extra property, like in this case, we're passing ID, which actually wasn't one of the properties defined, it'll fail. And so TypeScript continues to be beneficial in refactors. So it's getting in our way. I'm going to be honest, right? Having to define that structure ahead of time when we're used to just kind of throwing stuff and throwing properties away are what we're used to. Like, we like to be lazy at times, but we're also getting the safety that TypeScript provides, and you have to, we signed up for it. So that's the case there. And now, having developed in TypeScript for a while now, whenever I have to go back to vanilla JavaScript, it kind of feels unsafe, right? Because I never know if an object property exists or not. Okay, so let's talk about the last one, about props, okay? And this is my favorite one, probably. So let's say one of our props is not a simple type or an object type, but it's actually a function. And those are usually callback functions like onClick or whatever like that. And they're a result of some user action, typically. So here, ours is called onChange, right? And in the prop types world, the only prop type we have is prop types.func. And we can throw is required on the end of it, but we never get to specify like how many arguments are going to be passed to my function. Is it going to return some things? Like, there's no more detail than just saying that it's a function. So you just never know. But now in TypeScript, just like everything else, we have to define the shape of the function. So here it tells us that the function passes us one parameter, which is a string called new value, and that function must not return anything. And that's what the void there means. So if we make changes or if we add a second parameter to onChange, things will blow up, things will fail, and we'll know why. So, how many times have we forgotten to change a function handler after the fact, right? And these are mostly the result of user actions. So as we're manually testing, there's a chance we might miss some things. And unless we write like really good unit tests, we'll miss them. And, we don't really write really good unit tests, so we'll miss them, okay? So if you're wondering about that strange syntax for variant, that's technically called a union type. It's basically the equivalent of prop types.oneOf. So I'm saying that variant can either be the string filled or it can be the string outlined, and it can't be any string. So it's forced to be one of those. So I use VS Code for my development, and the integration with TypeScript is amazing, okay? If you don't know about VS Code yet, it's a free open source editor. It auto-completes React, so it'll tell you what properties are available and what their types are and such. That's their IntelliSense. And all those errors I was talking about, it will show those inline. So like as you're typing, you're getting these red squigglies to let you know if the prop is invalid, if its value is invalid, and everything like that. I can't imagine doing TypeScript without it. Okay, so we just talked about props, right? Yes, question.
So, do you ever use prop types in TypeScript at the same time, or is it
So the question was using prop types and TypeScript. So no, I don't use prop types anymore, because if I have a React app and all TypeScript, then I'm really getting a guarantee that things are being passed correctly. So the difference is TypeScript happens at compile time, right? And prop types happen at runtime. So the only advantage you would get with prop types is if you're getting data from an API, right? And that API, you don't know the structure, or it may change, and then you're passing in data that you think should be a string, but you're getting a number, then the prop types may help you. But that's usually in production where prop types don't run, so you don't really get much value out of it. Yeah, that's a good question. Yeah, you're welcome. So props are usually the most unique aspect of React and TypeScript, so that's why the main focus was on that. But there are some things about hooks as well. But React functions, hooks, are just functions in TypeScript, so it's really just standard TypeScript that I'm going to be talking about here. So let's look at some hooks, right? The first one being useState. So now that our props are fully type safe, we need to make sure our state is as well. That way, when our types are refactored, we can ensure that our app is correct. Okay. So generally, you don't have to do anything special with useState. It can infer the type based upon the default value we pass into it. So this is called type inference in TypeScript. So in this case, TypeScript infers that the value of count is a number because we passed in 0 as the default value. So setCount is the second parameter of the useState, as we can see there. And it is a function that accepts a number, and so that we can't accidentally pass a string or pass some other value. But here I'm using the updater version of setCount because the new value of the value of count is dependent on the previous value of count. So, but even here, the updater function, it verifies that I can only return a number and that this variable or this parameter, prevCount, is a number. If I pass anything into it, I'll get an error. But take a look at this code real quick. It's fully type safe, yet there are no types in it, right? So you don't always have to write TypeScript types. Depending on how your code is set up, things can be inferred. So it's actually pretty nice. However, if your initial value is null, then TypeScript will think that user can only be null. So we have to tell it different allowable types for it. So it will infer incorrectly. So here I am saying that the value of user, the variable, a state variable can either be a user object or null. And this syntax that you see there for useState is called generics. So if you're ever Googling it, it's generics. If you've ever used like Java or C#, the generics exist there. It's kind of similar. I never understood it when I did C#, but I understood it when I did TypeScript. So you can go the other way. But if you're unfamiliar with generics, I have a link here at the bottom. It's a video by Harry Wolf that goes into detail about that. So I know, here's useEffect. I know, yes, you got a question. Tell me. If we can use any? You can use any, but I am totally against any because any is just basically, can I use JavaScript again? And we're trying to not use JavaScript, right? We're trying to get into TypeScript. So there are different schools of thought. Some folks believe that, hey, when it's too difficult, just use any and move on. But then what was the point of going through the hassle of using TypeScript, right? So yes, you can use any anytime you want, but I say don't use it. Okay, so let's talk about useEffect. Generally, there's nothing special about useEffect because it's a function that takes no parameters, right? And we usually don't return anything from useEffect as well. Although you can return what's called the cleanup function, I guess. So if you look at this code, it's kind of sneaky here. Looks exactly like the code before, except that I'm using parentheses instead of curly brackets to define the function, which if you're familiar with JavaScript, that means it's an implicit return. So I'm actually implicitly returning a promise. So if that looks kind of esoteric to you, that's fine. But if you did it, you'll get an error that says that, hey, you can't return a promise to this. It can only be a function, a cleanup function. So we get this inline right there. React will complain again as well when you run the code, but we get this a lot quicker with TypeScript. I will say that there is a lot of unique things with useReducer. It's a little bit more complex than I wanted to get to here in our talk here, but I'll include a link at the end of the slides that goes into more detail. I wrote up a blog post about it. So finally, let's talk about custom hooks. So custom hooks are just functions, again, like I've been saying. So this is all just normal-ish TypeScript. So it's common, though, to return some data from a hook, right? Here, we're returning 2 pieces of data as a tuple. Basically, it's not a real tuple like in other languages, but it's basically an array with 2 items inside of it. So let me see if I can try to break this down. So what TypeScript will infer from this. So the tuple is a user object first in item 1, and it's a function set username, which will update the state in the second item, right? So user object first, function second, all right? But what TypeScript will infer by default without doing anything special is this is an array of either user objects or functions, right? So it's basically thinking that any item in the array can be a user object or a function. And the array can be any length. So that's what it infers by default, but that's not the truth. So when we go to use this useUser hook and try to destructure it, our types will be not what we expect. So there are a couple of ways that you can solve this problem. My preferred way is to use a const assertion. So that's that as const at the end there. And then it will say that, hey, this thing we're returning is exactly 2 items. And the first item is a user object. The second item is a function. So you also alternatively could define the type of the return value of the function and say that it's exactly what I described. And it's actually pretty straightforward to do in this case. But sometimes the return values are way more complicated and complex than this. So this approach, no matter what the return values are, seems to work fine. Okay, that was complex to describe, but we made it through. And again, the slides are there, so if you want to go back to looking at them, you're more than welcome to. So the last thing I wanted to talk about are some advanced patterns. So, if you've been here and you're like, This has been so easy. I do React, I do TypeScript. Ben, tell me something new. Okay, hopefully this will be that time that will pique your interest. So let's jump into some advanced patterns that you may see yourself dealing with. The first one is when a prop depends on another one, okay? So let's say we have this component here. It's called the text component. And it has a property called truncate, right? So that if the text is too long, you can truncate it to a certain number of lines, right? Just a common pattern, show more, see more, etc. And then we have the second prop that's called show expanded. So that's like, should it be expanded by default or not, right? So the show expanded prop doesn't really matter or doesn't make sense unless we're truncating, right? So the show expanded prop kind of depends on whether truncation is true. The truncate prop is true. So we don't want people to be able to specify show expanded without truncate, because that would make sense. So, and with prop types, that's kind of too complicated to express, but with TypeScript and some little bit of magic, I guess I'll call it, we could totally do that. So let's see how we can improve the developer experience so we can get this bottom case and get errors when people do that. Okay, here we go. So there are a couple of ways that you can set this up, but this is my preferred one. So let's break down this. So this is like kind of applying advanced TypeScript to React. Here we go. So first, we can define what I call the common props. So that's just what we were talking about in the first section. These are the props that exist all the time. They're always going to be there. There's no conditional logic, right? So then we can define a type that's called truncate props. So this is using what's technically called a discriminating union. It's basically a technical term to say that you can have one or two objects depending on certain cases. So if you're ever trying to look for this, it's discriminating union. And I don't know why it's discriminating, but it totally is apparently. The first part is the truncate prop. So if the truncate prop is false, meaning that they didn't specify it, or they set it to false, or they didn't specify it, then we're saying that the show expanded prop has to be undefined. Like it cannot be defined, right? So the translation is that. The second one is when the truncate prop is true. Then we can optionally pass show expanded. So it still has the question mark, so it doesn't have to be there. Can be omitted and defaulted as necessary, but it can only be there when truncate is true. So then the text props type is the intersection or the merge of the two. So we use the ampersand instead of the pipe. And it's the merge of common props that we define in the top and truncate props that we just were talking about. And then finally, we can use text props in our code. And both truncate and show expanded will be optional Booleans there. So don't worry if you didn't catch all of that immediately. I actually wrote a blog post that goes into detail. So if you want to kind of read it slowly and absorb the different TypeScript features, you totally can. But in this code, we're using optional properties with the question mark. We're using pipes, which define unions, and we're using merges or intersections with the ampersand, which are all common things you would use in TypeScript. Okay, one more. All right, let's talk about this one. So this is also common if you're building like a design system or a component library. So we want to have a button component, which is always like the start of a component library. And we want to have our component, our button component, wrap over the HTML button element. So it has some props that we want to control, like variant or size, right? Those are our properties. And we want all of the normal button properties like on click, disabled, and stuff to be able to be passed. And we want this all to be TypeScript, right? We already kind of do this stuff, right, without TypeScript. We pass all these unknown props to the underlying element. But there's no validation when we use vanilla JavaScript. We have to wait until the code runs, and then React will tell us whether or not a prop works. So how do we do this? Well, I'm glad you asked. Thank you. Instead, we can provide some TypeScript definitions. So let's look at that. So first, we define the extra props, I'm calling it. So those are kind of similar to the common props from before. Those define hours. So here I have variant, which can be primary or secondary. That's kind of how I read it, even though it's a union. And then we have size, which can be default or small or large there. And let's look at this section. So let me break this one down. So we have this type props. It takes extra props that we just found, and it tries to merge in all of the button props, right? So that is the React.component props of button. However, there's this weird thing in TypeScript where if you try to merge in properties from one object into properties of another object and there's a name collision, like TypeScript just craps out. And I don't know why that is. I haven't figured out why that is. If somebody knows why that is, please tell me. But in order to solve that, we have to do this omit part. So we use the omit utility, and we, with key of at the end, like this is like really fun TypeScript. And we use it to remove all of these properties of the button so that then we can merge it in. And that's what props ends up being. And then finally, we're now able to use that code and merge it all or spread it all into button props, and it's all fully type safe so that if somebody tries to pass in href to the button, for instance, it'll be an error. We did all that to make sure that those error cases can't happen. So I have a link at the bottom that describes the utility types like omit or required or things like that that are helpful. And again, I have a blog post at the end that describes all of that. Okay, so that was all of the kind of brain things, but I want to end by telling you that TypeScript is not a cure-all, even though I'm super excited about it. It catches lots of bugs, it catches a lot of errors, it solves a lot of problems too, but it's not a replacement for unit tests. It's not as much as we want it to be, right? It's not a replacement for code review, for instance. We still have to do those sorts of things, but hopefully we'll need to do less of them because of the things that are being caught. We don't have to test as many edge cases. And one question I always get, right, is do I have to switch over all at once? Like I have an app in JavaScript, do I have to stop everything and switch over to TypeScript? And thankfully the answer is no, right? I don't really believe in huge rewrites anyway. I don't think there's value in that and just rewriting the whole thing. The ROI is not there. But I suggest going component by component, actually, because with modern setups for TypeScript using Babel, a JavaScript component can actually, or JavaScript file that is, can import a TypeScript file just fine, right? So we already talked about using any. I don't think you should use any. So you want to kind of get something fully type safe and then import it into your existing JavaScript. So I suggest starting with like files that have very little dependencies. So like utility files, helper files, and things like that. And then you work your way out. So then you have a component that's using all these utility files, and then that's a small component. Then you have a medium component using all these small components, and then your last one you probably will convert is the outlying app. So another heads up, I already mentioned this, you're gonna find yourself fighting TypeScript at times. You like, I know this code works, TypeScript, just be okay with it. And that's gonna happen. But like I said, you are signing up for TypeScript when you decide to go with it. So, you have to catch those cases that will never happen, right? It may be, as Jared said at ReactConf like 5 years ago, if your code is hard to type, that might mean that your code itself is too complicated. And it's rarely just that you can just throw types on some JavaScript code. You may have to do some cleanup of the code itself. So if you're interested in going deeper into TypeScript, for instance, Waller here is going into that tomorrow at 10 o'clock, so totally check that talk out. Okay, shameless plug, he did not pay me to do that. But I know we're talking about React, but circle his talk on the schedule. As far as I know, we're going to be learning about conditional types, right, and mapped types and all kinds of crazy types, so check that out. So here I have a list of links. Obviously, you can't click the links by looking at them, but totally get the slides, and you'll be able to click those links. Lots of resources, lots of blog posts I talk about more advanced things there. So that's it. Hopefully you found this quick tour of React and TypeScript helpful. Hopefully it's motivated you to switch over to TypeScript in your next or even current React project. I want to give a shout out to Pratik and Vincent. I don't know if you know that, but they're the ones who put on Connect.Tech. They've been doing it year after year after year. Of course, for you all, just showing up for the talk, right? And like I said, the slides are online. Go to Twitter, go to my website, you can find it there. If you've got any questions, you can totally find me or ask me on Twitter. And I'll be happy to answer those questions. So thanks, and enjoy the rest of the conference. Thank you. So it turns out that the next talk is at 11:30. That's Corey. So I'm happy to take any questions that people have for like 5 minutes or 10 minutes or so. So if you got any questions you think will be helpful for folks, feel free to ask. The only thing I say is that none of us are interested in 2 minutes of explanation and then a 4-second question, right? Just stick with the 4-second question, and then let's do that, okay? So, deal. Who's got a question? Yes, ask. Will this work for server-side rendered components? Yes, it should, because again, there are just functions, so those will be typed. Good. Yes, good question. Yes, question. Which kind of components? Okay, higher order components. Yeah.
It seems like you have to kind of do the nested omissions of like props if you would have higher order components. Is that like a pattern you use?
Yes, I don't use that as much now. I usually use render props instead of higher order components. So a higher order component is a function that returns another component, right? So you can kind of think of it as a function that returns another function. And in that case, you shouldn't have to omit the properties because you're returning another component that has its own definition. So like now with TypeScript, higher order components should be even easier because you know what properties are being passed through. But there still could be those merge conflicts in the props like you're talking about. But you can more easily define those. So I don't know, it may actually catch those better because you will know what props you're passing in from one to the next. So I don't use them, but they should work if there are no name collisions. Yeah. And if there are, you would want to catch those. Anyway, yeah. Another question, yes.
So it's easy to kind of introduce TypeScript as you go.
Yep.
What sort of power do you need, what's the bare minimum, I guess, to introduce a TypeScript file into a big JavaScript?
Yeah, so basically there's a Babel setup you can do, which you're probably already using, and there's a TypeScript plugin that you can use. Yes, and it can coexist with them. You would probably you would just add it on to the ones you have at the end. It'll be the last plugin, and then it's the first step that converts your JavaScript to TypeScript, and then all your other plugins. What did I just say? Oh, convert your TypeScript to JavaScript, and then all your other plugins can run after that. Yeah, so look for, I think it's Babel plugin TypeScript. Don't quote me on that, but it's something along those lines. Yeah, look for Babel plugin and TypeScript, and it's in some order of that. Cool. Last question. Yes. Okay.
So if you have an interface and only being used in single file.
I didn't catch the last part. You have an interface.
You have a single file component, you want to add an interface to it.
Okay. Oh, okay. Yes, I typically, if it's a enclosed component, yes, I will keep the interface there. If I would only move the interface somewhere else if multiple components needed it for some reason, but for sure, I would keep interfaces for props there. And if for some reason one of the properties, like the user object we were talking about before, if that user object is used in multiple places or used for an API or storing state, then I'll pull that out. But the props I would keep inside. Yeah.
If you have a function that's only used in a single component,
Yeah. Yeah, so if the function, as his question was, if you have a function that's only used in the component, would you move that out or keep it in, right? So yes, I mean, it just depends on how you like to write your code. It's no real different when you add in types as well. So I would keep it internal as well. You shouldn't have to move it out. Yeah. Okay, great. Corey wants to come up and go next. He's talking about React and stories of how to use different React setups. So thank you very much again. Cool. Awesome.